So now, in the last video that I did, I put together this circuit here. So we have the NPN bipolar junction transistor. This is a 2N3904 wired as a current source. So current's going to go through the load and the transistor based on the voltage we set, minus 0.7 volts, and then the value of resistor that you use there. That will set a current along there. And so if you have 1 volt across this resistor, it's going to let, if we use a 1 kilo ohm resistor, 1 milliamp of current through it. 2 kilo ohm resistor will have half of a milliamp, and a 500 ohm resistor would have 2 milliamps. And so you can balance the voltage and the resistance. So we'll look at that really quick. So I'm pretty sure we have 2.7 volts to the base of the transistor. We will measure that. So we can go anywhere we have the negative rail. So right there, a little more than 2.7, and there you can see the same voltage. If we go there, we can measure either 2 points. So now let's measure the voltage across the resistor, about 2.1 right there. Same over there. So it's a 1 kilo ohm resistor, and so I have the circuit running. We could take those measurements. If I pluck this, the voltage will be thrown off right there, and that's because now current can flow freely through there. We don't have this current blocking it, and so we get a voltage drop, whether we measure there or we measure over there. So in any case, we will look at the current. We have about 2 volts across, and with this meter, you can just leave the red probe in one spot. We have about 2 volts across the 1 kilo ohm resistor, and so we expect about 2 milliamps of current. There we have the same load that we did before. Probes are backwards. That's why we had a negative voltage. Doesn't hurt anything though, or a negative current, I mean. There we can see we'll bypass one of the LEDs that are in series, same current, and the same current over there. We had 2.1 volts across 1 kilo ohm, and that's what we have. So we're using a trimpot, and I have the power supply set to 10 volts. That's actually probably why we were able to light 2 LEDs. Let's drop the voltage down to 5 volts, and we will get rid of one of the LEDs. That's not enough voltage now, but still we can power this pretty much the same. But we're using a trimpot to set the voltage. We're getting a fraction of the power supply voltage. So we had 2.7 volts right there. Now we're probably going to be about 1.35 volts. I'm guessing with my quick mental math here, and let's measure that. And there you can see about 1.4 volts, and so we're getting less than 1 volt to the resistor. So we cut the power supply voltage in half, but the trimpot voltage did go to half, but still it's the 0.7 volts, so that throws off that halfway. So with changing voltages, we saw that was 1.4 and then about 0.7, I think it was, across the resistor. Let's take that measurement again, and we will still get current based on the voltage across it. So we're probably going to have a little less than 8 milliamps of current, even with differing loads right there. So what we're going to do is, usually you use probably a Zener diode, and there you can see 0.8 milliamps basically, even if we bypass the LED. So what we're going to do, diodes like LEDs, they have a specific forward voltage. So here you can see that we can use a diode. This one's a Zener diode, and I've done other videos where we set a voltage with the Zener diode. So the Zener diode, you use reverse bias. With the LEDs, we're actually going to use them forward bias, but we're going to use them pretty much the same way. So I'm going to pop out this jumper that brings the trimpot output to the transistor. So now these are not influencing that circuit at all. And we're going to grab the multimeter again. So we're not wiring it as you see here. This is a Zener diode. Use a Zener diode reverse bias well reverse bias, it has its Zener voltage. So that's the rating. These LEDs, so I'll just cover that up, but that is the main thing. We're going to put the LEDs to the negative rail, and we'll be able to get the voltage. We'll put a resistor to the positive rail to put current through it, because you need that to build up the voltage. But ultimately, the voltage will depend on the forward voltage of the LEDs. So I'll move this over right there so we can make that connection. Now, we can measure the forward voltage with the multimeter again. And again, we can leave the red probe where it is. Let's go right here. So there is two settings for this right there. If we have a direct connection, such as across a jumper or anything else, that's probably very annoying on the camera, that beeping. But a direct connection is a short circuit, basically, very low resistance, and that beeps to let you know in case you can't look at the meter or something and you want to test for short circuits. We hit select though. Now it tests diodes and including LEDs. So you're going to see it light up. It's putting current through it, and you can see it's blocking about 1.8 volts before it starts conducting. The green LED, of course, blocks more voltage, even though it's brighter, as you can see. I think it's probably putting a milliamp of current through them, but the green LED is brighter. It's just naturally brighter, even though it blocks more voltage. So what we're going to do is, like the Zener diode, we're going to connect to the negative rail. But as I said before, we're going to forward bias this one. So we're doing the opposite of the Zener. It's forward bias just like that one. We're going to put the long lead, the anode, to the base of the transistor, short lead, the cathode there. And we're going to take a 1 kilo ohm resistor and go to the positive rail. Now, we can actually measure the voltage across the diode here. And before I do, I want to get this to start conducting, because this might throw it off a little bit. There we go. So a little bit of current goes through there. Without this passing current, more current goes though. Now current flows more easily this way. It helps build up that voltage that we have there. So let's measure the voltage across there. So about 1.9. So I expect about 1.2 across the resistor right there. And there you can see it's a little more than 1.2. So that's the voltage build up there. Well, current is going through the resistor. So the resistor's limiting the current based on the voltage across it. So this is also a 1 kilo ohm resistor. It's got 3.182 volts across it. So it's letting through about 3.2 milliamps of current. And since this is slowing down how much current goes through, it's just looking at the voltage. That's basically all the current going through the LED. And now I'll show you, if I pluck this, we'll probably have a lower voltage buildup across the LED. So actually it's about the same. So LEDs are pretty solid. That's actually the point of this video. So it threw off the trim pot, but it's pretty solid here. So what we're going to do is we look at that voltage one more time, make sure we have it right, and we should have, what was it, about 1.2 milliamps of current through the load, even as the load changes. So we'll go through an LED and we'll go to the transistor, same amount of current, and you may see this LED kind of change its brightness, so it is influencing it a little bit, even though I'm not getting the measurements that show that. Now we can pluck this one, the red LED, and use the green LED. So we already saw with the meter it has a higher forward voltage, and so now that we have, I'm guessing about 2.5, a little less than 2.5 volts going across this resistor. Let's take a look. I haven't measured the current. That would have been really bad. We would put current through the meter with no resistance and then through the LED. I do have current limited though from the power supply to 30 milliamps of current. So the LED probably would have got brighter than it should, and you may notice some of these red LEDs are not as bright as others. I put too much current through them before and they just don't get as bright anymore. And so in any case, we'll look at the voltage across the LED first, about 2.4. So we expect about 2.6 approximately across that resistor there, and that means that we should have plugged this. So that was without. Now you saw the LED got brighter. That was without the current going through there. So it did pull it down. I bet it's higher now than 2.4 volts. And there we go, about 2.6. So that's a thing with these circuits. And sorry you couldn't see all that. Do all these measurements, and while you're building circuits and stuff and different variations of the circuit, you learn all kinds of stuff, see interesting stuff. So in any case, we got about 2.5 volts there, 2.5 volts there. That's actually really nice. That makes it easy. A little more. So we'll have about 0.7 volts less across this resistor, which sets the current. Again, it's a 1 kilo ohm resistor, makes the math easy. And so we expect about 1.8, doing the mental math quick, okay, 1.9 right there. And so we expect a little less than 2 milliamps of current if we pull this jumper. So LEDs are not made, you know, they kind of have a general forward voltage. The more current that's going through them though, the higher it will be, but they have their base voltage too. And then even different LEDs. So there you can see we have that about 1.9 milliamps as we expected. So we can use the LED. Now, as I said before, the LEDs are not as finicky as a resistor-based voltage divider, such as the trimpot. So we're looking at this with 5 volts right now. And if we do 2 LEDs in series, we'll probably be thrown way off. So we had 2 milliamps of current. We're still in milliamps with 1 LED. And looks like this is blocking. Yeah, that's blocking so much we can't even get a current through there. So that is with 2 LEDs. What we can do is raise the voltage. In fact, we'll leave that there, and I'll show that again, and then I'll raise the voltage. So with the same load, can't do 2 LEDs, but we can do 1 or just the transistor. Now, without changing the circuit, I will go up to 10 volts right there. And this may have got a little bit brighter. We're going to have more current going through the resistor, and it will block a little more voltage and get a little brighter. It'll have a little more current going through it. And to get a more accurate estimate while we have a load, we can go like that. We can look at the voltage, and probably a little more now than 2.5. We had about 2.5 before, if memory serves right. So now we're up to about 2.9. So we got more current, but it's not twice the current. We doubled the voltage, and we have 10 volts at the power supply. So it's a little bit more voltage, but nowhere near like twice the voltage. So it does block a little bit more, but just a little bit more. Now we'll go across this resistor, and so we should have that 2.9, about 2.2 volts across here apparently. And there you can see. So we expect about 2.2 milliamps of current. If you remember right before, I think we had 2.1 milliamps of current before. So even though the voltage went up, and now we can do 2 LEDs, but the current is still about 2.2 right there. And we can even add another LED, and I think we could add, I don't think we could add one more. I think this was about the most we could do, because they're blocking about 6 volts total. Another one will block close to 8. I think that would be a little too much, especially with the 1 kilo ohm resistor there. But as you can see, the Zener is commonly talked about. So we have the circuit there, same circuit, just there's a Zener diode that sets a voltage. It's reverse biased. So these LEDs are forward biased. So for the Zener, the cathode's up there, anode towards negative. The LEDs, the arrow is pointing this way, and so the dash is towards the negative, and then the larger side is towards positive with the LED. But there you can see it sets a voltage pretty nicely. And LEDs are common, so if you don't have a zener of the value you need, instead of a reverse bias zener, maybe you can use some forward bias LEDs or other diodes. They block about 0.7 volts. You can stack up those block voltages. They will just add up. But for this video, that's it. I just kind of thought of this situation. Thought I would do a quick video. So I didn't make a diagram or anything. But hope you still enjoyed. Thanks for watching. I'll see you in the next video.